Morning, students. Yesterday, we looked at this new topic in this unit, data analysis and visualization. So the topic was understanding the scope of data science and the rules on data scientists. We looked at the unit aim, we looked at the content and the definition of data analysis, the key aspect of data analysis and how data analysts help organizations. We also looked at the skills. We checked how to become a data analyst, among other things. We also defined what is data abstraction, the different Python libraries for data abstraction. We looked at data visualization, the types of data visualization, which involves charts, maps, infographics, dashboards, and so on. We also looked at the techniques and tools of data analysis activities. So we looked at the activities, we looked at data cleaning and preprocessing. We also looked at the techniques and the tools of the tools of a data analyst, which involve programming language, data visualization, statistical package, data mining, among other things. And we also look at evaluating the three types of data analytic methods and their use in the industry: descriptive analytics, predictive, and prescriptive. We also looked at a problem and the solution to it, and we also saw the code. And we looked at the explanation of the code, and that was all. But most importantly, we watched this video that broke the definition and the meaning of data analytics for us. So today, we'll be looking at this new topic called evaluate a range of predictive analytic techniques to discover new knowledge for forecasting future events. That's what we'll be looking at today. So this is the indicative content. We're looking at linear regression, multiple linear regression, logistic regression, qualitative, average approach, naive approach, time series methods, causal relationship, use R or Python for forecasting modeling. As usual, we have a video to watch.
Find your perfect package holiday.
But we'll be looking at the video right after this session. So the next topic will be compare a range of predictive analytic techniques for forecasting purposes with example. The first one is time series analysis. The second one is regression analysis, machine learning algorithm, ensemble methods, and Bayesian method or Bayesian method. What is time series analysis? If we're looking at the first one, which is time series analysis. So what is time series analysis? This analysis focuses on analyzing and forecasting data points collected over time. It involves examining patterns, trends, and seasonality in the data. Methods commonly used in time series analysis include ARIMA, that is autoregressive integrated moving average models, exponential smoothing models such as hot winters, and state space models. Example of time series forecasting include: 1, stock market prediction. So this is used to predict, or this is used to forecast future stock prices based on historical price data. The next one is energy demanding energy demand forecasting. This is for predicting electricity consumption for efficient grid management. Another example is sales forecasting. Forecasting future sales based on historical sales data. The next one is regression analysis. So what is regression analysis? This aims to model the relationship between a dependent variable and one or more independent variables. It can be used for forecasting by fitting a regression model to historical data and using it to predict future values. Examples of regression-based forecasting include demand forecasting. This involves predicting the demand for a product based on factors like price, promotions, and demographics. You also have economic forecasting. This involves forecasting GDP growth or unemployment rate using various economic indicators. We have customer life value, CLTV prediction. This involves estimating the future value of a customer based on their past purchase history and behavior. The next one is machine learning algorithm. So these techniques involve training models on historical data. This involves training model on historical data to make prediction or classifications. Several algorithms are commonly used for forecasting purposes, including one, random forest, an ensemble algorithm that combines multiple decision trees to make predictions. It can be used for predicting sales, customer churn, or stock prices. We also have gradient boosting. This is a technique that sequentially builds a strong predictive model by adding weak models. It can be used for predicting customer behavior, fraud detection, or demand forecasting. We have neural networks, deep learning models that can capture complex patterns and relationships in the data. They are used in various forecasting applications, such as weather prediction, natural language processing, and image recognition. The next one is ensemble method. Ensemble methods combine multiple models to make more accurate predictions. Examples include bagging. This means combining predictions from multiple models trained on different subsets of the data. It is used in applications like credit risk assessment and disease diagnosis. We have stacking. This is combining prediction from multiple models by training a meta model on the outputs of individual models. It can be used for customer churn prediction, or sentiment analysis. Bayesian method. Bayesian forecasting utilizes Bayesian inference principles to make prediction by incorporating prior knowledge and updating beliefs based on observed data. It is particularly useful when dealing with limited data or when prior knowledge is available. Examples include Bayesian time series models. This involves incorporating prior information and updating it with observed data for forecasting economic indicators or market trends. Bayesian regression, incorporating prior belief about the relationship between variables and updating them with new data for better predictions. So if you want to know more about this, you can check what So there are loads of Google links that can help us more understand what we're talking about. And you can also go to YouTube to watch some videos about it. The next topic is evaluate how predictive analytic techniques can be used for forecasting purposes. Time series analysis, regression analysis, machine learning methods, Bayesian methods. What is time series analysis? Time series analysis techniques such as ARIMA models, exponential smoothing, and state space models are specifically designed for forecasting based on historical time-dependent data. These methods capture patterns, trends, and seasonality in the data and use them to make predictions. They are particularly effective when the data exhibits a clear temporal structure. Time series analysis is commonly used for forecasting in domains such as finance, sales, inventory management, and demand forecasting. Let's check what time series analysis, more about time series. So we have this. We have time series is a specific way of analyzing a sequence of data points collected over an interval of time. In time series analysis, analysts record data points at consistent interval over a set period of time, rather than just recording the data points intermittently or randomly. So this is an example of time series analysis and why organizations use it, among other things. What is regression analysis? Regression analysis allows for modeling the relationship between a dependent variable and one or more independent variables. It can be used for forecasting by fitting a regression model to historical data and using it to predict future values. Regression-based forecasting is applicable when there are identifiable factors or predictors that influence the variable of interest. It is used in various domains, including economics, marketing, supply chain management, and customer behavior analysis. The next one is ensemble methods. Ensemble methods combine multiple models to improve forecasting accuracy. By leveraging the diversity of different models and combining their prediction, ensemble methods can capture a broader range of patterns and reduce individual model biases. Ensemble techniques like bagging and stacking have been successfully used for forecasting in domains such as finance, credit risk assessment, and customer churn prediction. We can also check what ensemble So over here, we see the definition of ensemble methods. So they say ensemble methods are techniques that aim at improving the accuracy of results in models by combining multiple methods instead of using a single model. The combined models increase the accuracy of the results significantly. This has boosted the popularity of ensemble methods in machine learning. So we have a backend boosting stacking, among other things. So the meaning of bagging, boosting, and stacking. You can also like just Google it to better understand what it means. Machine learning algorithm. By Bayesian forecasting techniques incorporate prior knowledge and beliefs into the forecasting process. By combining prior information with observed data, Bayesian methods provide a principal framework for updating beliefs and making predictions. They are particularly useful when dealing with limited data or when prior knowledge is available. Bayesian forecasting has applications in areas like finance, economics, healthcare, and market research. So these are the advantages and the limitations of Bayesian method. The first advantage is the ability to capture complex patterns and relationships that may not be apparent thoroughly through traditional methods. The next advantage is flexibility to handle different types of data, such as time series, categorical data, and unstructured text data. The next one is the capability to incorporate prior knowledge or domain expertise to improve forecasting accuracy. Potential for automation and scalability, enabling the analysis of large data sets and the development of real-time forecasting models. The limitations, dependence on the quality and availability of data. Accurate and reliable forecasts require high-quality data without missing values or outliers. Assumptions and constraints of specific techniques need to be carefully considered and aligned with the nature of the data and the forecasting problem. Interpretability of complex models, such as neural networks, may be challenging, requiring additional efforts to understand and communicate results. So our next subtopic, is apply an appropriate tool or programming language to demonstrate predictive analytic techniques. So what you need to do is to download Anaconda on your desktop, download the latest version of Python, open Jupyter Notebook, install the relevant libraries, implement your code. So if you want to download Anaconda, for people that don't know where to download Anaconda, I use a MacBook, so this is where I'll download it from. Well, if you use Windows, you can click on the Windows icon. It will take you to the Windows page, and you'll be able to install it. And if you should use Linux, you can just click here and download it from Linux. And this is the documentation on how to install it on Windows. You double click it, click next, and install. These are the libraries that will be used. And you can also try this code here for linear reduction to predict the model. Just to make sure that we understand it better, you can also check YouTube for it. Okay. Here's a YouTube video.
Work. Having a place that provides a vision.
Hey guys, in this video.
But before that, let's watch this first to better understand what
is it that R is becoming such a popular and useful tool in data analysis and statistical analysis? I'm going to tell you why. Stay tuned. Now, the short answer is, this is one of the rare occasions when something that is free and open source is in fact better, and that this is, in my opinion, better than the expensive commercially available alternatives that are out there. And if you don't believe me, just look at the trends. There are masses of people moving from SPSS to R, from Stata to R, from SAS to R, I don't see anybody moving the other direction. Now, R is essentially a programming language, and you might find that fact a little bit intimidating or scary, but don't. And you'll see when I do the little demonstration at the end of the video that it's not difficult to use, that it's relatively intuitive, and you can learn it. And there's loads and loads of support out there if you need it. The importance of using code when you do data analysis is that your analysis is reproducible. Somebody else can see exactly how it is that you got to the answers that you got to. Added to that, you've got the ability to collaborate with other people, and they can look at what you've done and make suggestions or changes or identify mistakes in your analysis. And you can't do that with a point-and-click system. And the next reason why using code to do your analysis is important is that not only is your analysis reproducible, but it's also repeatable. In other words, if a year from now you've got additional data, let's say you had data for 2018 and in 2019 you've got double the data set, you want to rerun that analysis, you just run your code, and everything, your data cleaning, your data manipulation, and your analysis all gets repeated right there and then at the push of a button. One of the most exciting things about R is because it's open source, you've got people all over the world writing packages, and packages are things that you can install and use that deal with very specific data analytic problems. And these are free, and there are literally thousands of them. Another big advantage of using R is that it has incredible data visualization and graphics capabilities. In fact, in that sense, it beats any other package hands down. It's a slam dunk, nothing comes close. Right, now I'm going to do a short demonstration just to show you that using a programming language to do analysis is not difficult, it's not scary, it's relatively simple. Okay, so watch this. Okay, so in this particular example, I have got a little data frame called friends. I click on that and we can see it over here. We've got some variables and some observations. I'm looking at age and height. Let's see what we can do with those. Basically, the way the coding works is you apply a function to an object. So in this case, the function might be the mean. We want to know the mean of age, which is the object, which is 23. We might want to know the median, the height. We can plot a histogram of age, or plot age against height. We might want to know if there is a statistically significant correlation between age and height. And as we can see in this particular case, there isn't. Right, so clearly writing code is not that scary at all. I mean, I haven't broken out into a sweat. You'll notice I don't have a tremor. I don't have a heart palpitation. I haven't fallen over dead. I've actually survived. It's not difficult. It's not scary. You can do it. Now, if you're interested in learning R, then why don't you subscribe to this channel, follow the videos. I'm going to start off by just talking you through how to install R, how to install RStudio, which is where you're going to write the code. And then we're going to go through everything, data analysis, data manipulation, data visualization, all the way up to machine learning and AI. Thanks for watching. Leave your comments and questions in the
I used one simple webinar presentation to produce $2 million in the past 12 months. It was 100%.
In this video, we will install Anaconda Python and launch Jupyter Notebook and run a sample Python line. So let's get started. First of all, open your Microsoft Edge, Chrome, or any other browser and go to Anaconda download. And you can just click on this button, or let me just click on this page so that we can see how to go to download from website. Now, once anaconda.com is open, as you can see here, as it is open, you will see this page and you can just click on download. And right away, the download will start. As you can see, it is 787 MB, so it will take quite some time. So as you can see here, our Anaconda is downloaded. So now you can click on open file or go to the folder where it is downloaded and just double click on it. So once this is open, you will see something like this. Click on next, click on I agree, click on just me or all users. Now, if you click on just me, this will only be visible to the user that currently you are logged in as. So right now, I'm logged in as Vishal Shrestha, so it will only be available for Vishal Shrestha. Okay, so but if you want it to be available to all the users, click on all users. Right now, I'll just install it for me. click on next, and this is where Anaconda will be installed. If you want, you can change the directory, hit next, and you can leave all these three options unchecked and click on install. So as you can see here, it is showing completed. Now you can click on next again, uncheck this, and uncheck this also, and hit finish. All right, guys, now our Anaconda is completely installed. Now press on Windows button and type Anaconda. So you'll see these two things here. So Anaconda prompt is using command line and Anaconda navigator is using GUI. So click on Anaconda navigator. We will open up command prompt and it will take some time to install and initialize for the first time. So be patient with this. So now you can see Anaconda navigator is open and it is still processing here. Now you can see a bunch of options here. As you can see, like Jupyter Lab, Notebook, and all this good stuff. Our Anaconda is installed and now we are successfully open in our Anaconda navigator. In your Anaconda navigator, you will see a lot of other packages and other softwares. Now to install and open Jupyter Notebook, you just need to click on this launch in this Jupyter Notebook section. Click on launch. It will take some time and launch Jupyter Notebook for you. Our Jupyter Notebook is open. From here, you can go inside any other folder and create a new Jupyter Lab notebook. So let's say you want to create a new Jupyter Lab notebook. You just click on new, choose which kernel you want to use. Just click on Python 3. And your new Jupyter Lab notebook is open. So just write a Python line here. Let's say we want to print hello world. Now hit Control and Enter to run this. As you can see, hello world is run. So now you can use your Jupyter Notebook and create interactive Python applications. If you have any questions, let me know in the comments below.
Yeah, so this brings to the end of our class today, and these are the references for your personal use. Don't forget to send us your assignments or any queries, send an email to us. So just to recap, today we spoke about data analysis and visualization. We spoke about the methods, which includes Bayesian method, ensemble methods, machine learning algorithm, regression analysis, among other things. We also watched a video on YR. And also, just before we go, I think it makes sense for us to check how to install R.
So why is...
So give me a second. Yeah, so you can watch this video.
In this video, we're going to talk about
on how to install R. We've already seen how to install Anaconda. Also check this video on how to install R, since we watched this video on R. We also looked at the time series analysis on R. So thank you for attending the class, and I hope to see you next weekend.